Good morning, grade 7. We will now have our continuation of the topic. Let's move now to water pollution. Okay. We actually stopped last meeting in air pollution. Let's move now to water pollution. Okay. Industrial activities produce industrial waste that enter seas, rivers, and lakes. These waste deplete the supply of dissolved oxygen. Remember that in your ocean and seas, okay, it has a lot of dissolved oxygen. When can we have this dissolved oxygen? Take note that there are marine life organisms living in the oceans and seas that actually performs photosynthesis, and they release again oxygen in the ocean and the sea. This oxygen is actually maximized by the marine life living there. Okay, they're called aerobic organisms because they will actually use oxygen in order to survive. But because of these waste materials, okay, dissolve oxygen lessen and again threaten the marine life. Okay, phosphates in detergents and fertilizers is an example of water pollutant. Your detergents, okay, detergents, sabon, okay. What else? Um, the fertilizers used, okay, in farming, these can actually pollute the water. Phosphates that enter the seas, rivers, and lakes stimulates the growth of algae or alga or algal bloom, okay, which consequently, if not intervened, okay, would result to algal bloom, okay, and the subsequent death of and odorous decay of large amounts of plant animals or animal life. This condition is called eutrophication. The algal bloom, okay, because of this phosphate, okay, there is a certain um algae that will grow faster, okay, in faster speed that consumes a lot of oxygen or dissolved oxygen. Okay, again, this condition is called eutrophication. Mercury and lead. Okay, what about mercury and lead? Okay, as industrial waste further cause contamination of water. Mercury in water is absorbed by fish, the bigger fish, through the gills during respiration. Okay, in humans, the ill effect of mercury poisoning can be irreversible and fatal. Okay, lead poisoning causes headaches, dizziness, and insomnia. Okay, in acute cases of lead poisoning, okay, there is a stopper progression or progressing of coma or to coma and terminating in death. Okay, it can actually cause death or death causing. Atmospheric interaction. Okay, because of this pollution, let's take a look at what could be the atmospheric interaction, okay, in connection to this. Okay, our atmosphere has been responsible for the development and the protection of life on our planet. Take note that we are receiving a lot of radiation from the sun. Okay, however, most scientists agree that the composition of the atmosphere is gradually changing because of human activities. Number one, human activities.
Like
And these,
global warming,
yes, this actually leads to global
air
warming.
pollution, light pollution.
Pollution is the cause. As you can see, we are discussing pollution from water to air pollution and so on. So let's take a look at now the effect. If there is a cause, there should be an effect of that particular cause. These changes might eventually lead to other changes in Earth. Let's take a look at the changes. But before anything else, let's take a look at also the layers of the Earth's atmosphere. Okay, covering the Earth is a thick blanket of gas in the atmosphere. Okay, the different layers of atmosphere help protect Earth from the large number of meteors that could crash on Earth's surface and cause extensive damage. The atmosphere also protects Earth from harmful rays of the sun because this is actually ultraviolet. Okay, the atmosphere is divided into 5 layers based on the temperature change with elevation. Based on the temperature. So in every rise, or if you're going to check on the atmosphere, it has different temperature per elevation. Troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So let's take a look at this. Okay. This is actually the whole layout of the atmosphere. As you can see, you can actually see here the troposphere. Okay. The stratosphere. Take a look at the temperature. Okay. The mesosphere. There's a rising temperature here. Okay. Ionosphere. And the exosphere. Okay. What's with these spheres? What's in these layers? Okay. The troposphere is a layer nearest to Earth and contains 75% of gases of the atmosphere, as well as dust and water vapor. This is the zone where weather occurs. Again, zone where weather occurs is the troposphere. Also, temperature decreases with increasing height in troposphere. If you actually go beyond troposphere, it actually temperature decreases. It actually decreases in temperature. Near the top of this layer is about 11 to 16 kilometers of Earth's surface, a boundary called tropopause. There is a boundary, okay? There is a boundary per what? Per layer, okay? Troposphere acts as a ceiling to weather zone, okay? Tropopause also contains stormy winds called jet streams, okay? This is also where you actually what? You experience what? Turbulence during when you ride airplanes during stormy winds or stormy weathers. This is the area where you experience this turbulence. Have you tried riding an airplane?
No.
Experience turbulence?
Not yet, but I almost did.
Yeah. Turbulence is when the airplane actually what? Experience what? Shaking. Okay. Sometimes when you travel, okay, in a stormy weather condition, you can actually experience turbulence. And this happens when and the airplane actually what? Shaken. Okay. Because it actually what? Passes through jet streams. Okay. Above the tropopause lies the stratosphere. So again, this is now, if you're going to look at it, troposphere has a roof or ceiling. Oh, this is the ceiling, tropopause. After tropopause, you have stratosphere, okay, which extends upward for about 50 kilometers from the surface of the Earth. Okay, in the lower part of the zone, the temperature is near constant at about negative 50 degrees Celsius. Okay, however, the temperature begins to rise with the height to about 0 degrees centigrade. Okay, this is the, if you're going to look at it, what is the freezing point?
Minus
What is the
negative 50.
What is the freezing point of water?
What?
You don't
What?
freezing
Freezing point of
water.
water?
Yeah.
What?
Huh?
I
You
couldn't
don't
hear
know?
you.
Huh? What is the freezing point of water?
0 Celsius.
Come again?
What?
What is
Jaden
the
said 0 Celsius.
what is the freezing point of water again? Make it louder.
0 Celsius.
0 degrees centigrade or Celsius. Okay. So the temperature there is negative 50. Meaning to say this is more than the what? More than the freezing point of water. Okay. And however, the temperature begins to rise with the height to about 0 degrees centigrade. So this is now the freezing point of water. Meaning to say, this is just for you to compare how cold is that area there. Okay. The stratosphere contains the layer of ozone, your ozone layer, okay, which keeps most of the ultraviolet radiation from reaching the Earth's surface. Okay. This is the area where Earth is actually protected by the what? Harmful UV rays or ultraviolet rays from the sun. Ozone is formed when three atoms of oxygen form one molecule. Okay? The oxygen that we breathe has two atoms of oxygen, that's O2. Okay? Ozone is O3. Okay? Ozone is excellent absorber of ultraviolet radiation emitted by the sun. But what is happening, what is really happening now is that this ozone depleted already. Here's the problem. So again, let's take a look at the gradual effect of this. The zone in which the temperature is at the highest is called the stratopause. Okay, again, this is the roof or the ceiling. Okay. The stratopause separates the stratosphere from the next layer of the atmosphere called mesosphere. So what's with the mesosphere? This is which about 50 kilometers to 85 kilometers above Earth's surface is the coldest zone of the atmosphere. This is the coldest. Near the top of the mesosphere, the zone is called the mesopause. Okay? This is the roof or the ceiling again of the mesosphere. The temperature decreases to about negative 80 degrees. Remember the freezing point, that's 0 degrees. This is negative 80 degrees. This is really cold. Beyond mesosphere is the thermosphere, which extends about 80 kilometers upward to 500 kilometers. Due to the absorption of solar energy in this layer, the temperature increases rapidly, okay, with the altitude. Within this layer is the ionosphere, which is layer of electrically charged particles. Ionosphere, ions. It contains ions, okay? The ionosphere contains ions that are formed due to the bombardment of atmospheric particles by the energy of the sun. Okay, ionosphere. These ions are useful for communication because they reflect radio waves. As a result, radio messages can be sent over very great distance through this layer. So we actually maximizes this layer. Okay. Occasionally, the ions glow in different colors due to solar flares that hit ionosphere. Okay. When this happens, the display is colored. Then the display of colors are called aurora, of course. We have two auroras, Aurora Borealis and Aurora Australis. Auroras are brightest at the poles due to the deflection of the particles or deflection of the particles by Earth's magnetic field. Auroras may cause disturbances in radio, of course, okay, television, and telephone transmissions. Okay, this is Aurora Borealis. Australis is different also. Okay. Above thermosphere, do you have any questions so far? Can
No.
you hear me?
No.
Yes, I
Yes.
can hear.
Okay. Above thermosphere is from about 500 kilometers to 3,000 kilometers above Earth is the exosphere. Exo means outside. Exo. Okay. Farther beyond this layer, at 3,000 to 30 kilometers above Earth's surface, is the Van Allen belt. Okay, which is a radiation layer formed by the concentration of particles of solar winds that are held in place by Earth's magnetic field. Okay, above it, above the exosphere is the Van Allen belt. Okay, the atmosphere and solar radiation. Talking about the atmosphere, what had you observed? Okay, their characteristics. What have you observed with the Earth's atmosphere? What have you observed? What have you observed based on our discussion?
It's massive.
It's massive, yes. Yes, it is. What else? What have you observed?
Bluer.
Come again, Kaizel?
It became bluer.
It became bluer. Yes, because this is the reflection or the The bouncing of light in your eyes, it reflects blue. What else?
All types of atmospheres, maybe.
What have you observed in the
All of
atmosphere?
it goes to space.
Yes,
The temperature.
correct. Okay.
Decreasing slowly.
Great observation, RJ. The temperature there actually changes from time to time. As you can see there,
Wait. So in space there is no it's 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 really cold there. You just freeze.
yeah,
You freeze in space. I
yes,
thought you explode because there's no oxygen.
it depends upon what else?
The altitude.
The altitude. As the altitude rises, what happened? Okay, the altitude. What's with the altitude there? Have you observed with the altitude?
The numbers are going higher in the altitude.
Okay. The numbers higher in altitude, yeah. When the numbers higher in altitude, what happened? What's with the altitude?
No air.
The air. Okay. So there you go. All of those are correct. Okay. The higher the altitude, you can actually observe also the changes of temperature.
Of temperature.
As you can see, the temperature changes from time to time. Okay. It could be colder in that area. And of course, in the next layer, hotter and go back again to colder. This is because of the composition of this layer of the atmosphere. Okay, this is how we are actually protected by the atmosphere. Okay. The atmosphere and solar radiation. So because we are actually affected by the solar radiation, let's take a look at what are the actions of the atmosphere. Okay. Global temperature that we feel on Earth is the result of two factors. We have actually two factors. The visible light is converted into heat when solar radiation strikes Earth's surface. Visible light, some of the ultraviolet rays and infrared radiation may reach Earth's surface. Okay. It will be converted into heat, just like when you're actually staying at home. And yeah, as you can observe, around 12 in the noon, okay, and you're staying at home, even though you're not exposed to the heat of the sun, but you can actually feel the heat. Why? Because this visible light is converted into what? Into heat. Okay. Again, the law of thermodynamics says that energy cannot be created nor destroyed, but it can be transformed from one form to another. So this is now energy transformation. It actually transforms into heat. Okay. Sunlight is absorbed by land and oceans, warming the planet's surface. Some of these energies used to evaporate water or to heat object on the surface. The energy is absorbed. The energy is absorbed, is converted into thermal energy or heat energy. Okay, this is really important. Why? This solar radiation also, the sunlight or the light coming from the sun or the heat that actually come from the sun helps in the water cycle. Are you familiar with water cycle? Are you familiar
No.
with water cycle? Okay.
No.
To give you an idea, water cycle powers up all the cycles. Okay. Why? When you say water cycle, it started with evaporation of water. Okay. Then the water in the atmosphere converted into water vapor, and the water vapor there starts to condense. Okay. Once condensation started, yes, this is actually in the lower grade, grade 3, yes, correct. Water cycle. We actually taught you with water cycle as early as possible because this is the mother of all cycles. This is actually the one powers up all the cycles, even the mineral cycles, the erosion, okay, the soil cycle, okay. This actually powers up everything in the cycle, in the nature. Okay, once there is condensation, okay, and after condensation, precipitation will go in after. Okay. The second is the heat is absorbed close to the planet's surface by greenhouse gases, your CO2, your chlorofluorocarbons, and so on, such as carbon dioxide, methane, nitrous oxide, and water vapor in the atmosphere. Okay, the atmosphere freely transmits the sun's shortwave radiation but traps Earth's long-wave radiation. So tendency is, what happened to Earth? It will become warmer to hotter. Okay. It is mainly the water vapor concentrated in the lower layers of the atmosphere that acts like glass. Okay. So instead of reflecting light or heat, it actually absorbs light and traps heat because of these gases. The water vapor is almost transparent to the sunlight coming in, but water vapor absorbs much of the long wave radiation going out and coming in. Okay, the vapor sends some of the radiation back to Earth's surface, and this produces the so-called greenhouse effect. Okay, again, I am already telling you a while ago about the greenhouse effect, that it actually what traps heat. Okay, this warms the Earth's surface and lower the lower atmosphere. Okay, so this is the greenhouse effect. From the solar radiation, okay, most of the radiation absorbs the Earth and warms it, and instead of reflecting back to atmosphere, okay, it actually absorbs the light or the heat there absorbs by Earth, okay, because of these greenhouse gases. And take a look at this, it warms and making the Earth hotter. There are a lot of effects with regards to global warming, okay, with the greenhouse effect. Greenhouse effect and global warming. So this is now the effects. Okay, energy from the burning fossil fuels, a process that produces carbon dioxide, has increased as a result of rising of global population. Okay, this shows that the population growth will continue to contribute to increased concentrations of greenhouse gases. We're actually creating the greenhouse gases. One great impact or one great contributor to the greenhouse gas is the burning of fossil fuels. What are these fossil fuels? Your oils, your gasoline, your diesel. These are fossil fuels. Okay. Once you burn that one, it will produce carbon dioxide, and these carbon dioxide emissions will actually stay in the atmosphere. That's the problem and can cause greenhouse effects. Okay. They contribute to the increased concentration of greenhouse gases in the future, resulting in the increased global warming. Okay. The bulk of the greenhouse gas emission results from human use of fossil fuels such as petroleum, natural gas or coal, methane and nitrous oxide that came from industry or come from industry, agriculture, and waste management are also contributors of global warming. We are actually creating global warming. It is a global phenomena, correct, but the main cause there is the human activities. We are actually creating that. Okay. And we are complaining that, oh, it's so hot. Oh, we're changing the climatic condition. And that is because of our global also phenomena, the global activity that we are actually doing. We're maximizing the non-renewable resources that we have. Okay, our coal and our fossil fuels, the petroleum. We're using petroleum, correct? We're using it in our cars. We're using it in our when we do cooking. We're using petroleum. Your LPGs is a petroleum gas. LPGs, gasol. That's your petroleum. Okay, we're using that one in cooking, correct? Are you still with me?
Yes,
Yes.
sir.
Okay, so we are a great contributor to global warming. We're complaining about global warming, but we fail to analyze, we fail to accept the fact that we are one of the major contributor for global warming. Okay, let's stop in global warming. Okay, greenhouse effect and global warming. Let's continue with air pressure and the atmosphere by next meeting, hopefully. Hopefully also you learn something out of our discussion. And heads up, by the third week of the month, we will have our mastery test. So this is the coverage for the mastery tests. At the same time, this is also the coverage for your what? For your project. Diba? I'm telling you a while the last meeting about your project. I already
Yes, that in
uploaded
fourth
again.
grading we will have a project.
Any
Yes.
narrative example?
Okay. Your project, I will just give you the inputs here. I still have around 6 minutes, so this is ample time for us to discuss about your project. Okay, I will let you see some of the samples of your project, but before anything else, okay, your project is actually categorizes into two. There are two categories for your project. Okay, create a learning resource out of our topic for the fourth quarter, module 1, weeks 1 to 4. So this is our topic, correct? The Philippine environment and its resources. So
Yes.
under it, there are a lot of concepts, correct? Science concept. So under it, you can actually create any of them. Okay. It has two categories. Main categories, you have the digital output and the physical output. Okay. When we say digital output, it is in a blogging form or a video documentaries. This is narrated. For the physical output, the second category, we have the 3D science concept. You can actually do the 3D science concept, a diorama of the concept, miniatures of the science concept, or possible the actual science concept. Okay. Again, I am encouraging everybody to make a physical output since it has the biggest grade compared to digital output. Okay. Make it as attractive as you can possible with your own creativity in any materials of your choice. Okay. Take note that this is your output for this school year, and it will be exhibited as soon as we are allowed to do so. Okay. I will also be in school every Friday to check on your outputs. Deadline for the submission, just to give you a heads up, the deadline is this May 13, 2020 at 5 p.m. Okay. So if it is a physical output, do not forget to write your name or include or indicate your name in your output. Okay. Again, it should explain the concept because this is a learning resource material. It should explain the concept. I will just give you one example. This was created by my previous student. Hold on. Teaching resources, learning resources. And let me share my screen. Can you see my shared screen now?
Yes.
Okay, this output is actually in 3D form. Okay, this is a 3D heart. As you can see, it explains the concept, correct? Correct? Take a look at the blue one. The blue one indicates carbaminohemoglobin. So meaning this indicates that the blue one carries carbon dioxide containing blood. Okay, the red one, okay, you take a look at the legend. The red one indicates oxyhemoglobin. Oxyhemoglobin means it carries oxygen containing blood. Okay, as you can see, if you're going to flip it over, if you're going to open it, you can see the flow of blood. Okay, the blood flow and the parts of the heart, the inner parts of the heart. The inner parts of the heart is actually written on the legend and how the blood actually flows and going back to the heart. Okay, this is one good example. Some of my students are creating diorama. Some of them are creating miniatures. Okay, so these are just few of the concept. These are just few of the 3Ds that we have, the learning resources. or the learning resource material that you're actually making. Okay. For computer 7, no, Kaizel, you need just to choose one. It could be digital or physical. Okay, but I am actually encouraging you to do the physical one because that one will be exhibited. We need to exhibit that one, and I will place it on the laboratory. Okay. What do we have? What do we have to discuss? Any? No, you need to discuss about the concepts that we have in the fourth quarter. Module 1, weeks 1 to 4, the field environment and its resources. Remember that we are tackling all of those, correct? You choose the concepts there. Okay. Yes, it could be the atmosphere, it could be global warming, it could be greenhouse effect, it could be any inside the topic, inside the concept. Okay. What else? Any other question?
No.
No.
Okay.
Wait, do
For your-
we send it at school, right? To school if we do
Yeah.
physical output.
Yes. You need to send it in school. Okay. Put it in the red room, I think. Okay, I will just let you know. Okay. I'll just let you know. Or you can actually put it in my box in school. Okay. What else? Any other question? You don't know what box?
No.
I have it in school. You just need to ask the teachers there. Or you can submit it to the teachers, have them